Okay, so we continue talking about inverse functions. And um, first of all, in order for a function to have an inverse, it has to be a one-to-one function. Okay, and one-to-one means that not only each x has only one output, y, but also each output y corresponds to only one um, input x. So this function, if it's a one-to-one function, it not only passes the vertical line test, but it should also pass a horizontal line test. So for example, if we have a function like y squared, x squared, y equals x squared, this function, it passes the vertical line test, right? So each line crosses the graph only once, but it will not pass the horizontal line test because the horizontal line exists, which crosses um, the line twice. So this is not a one-to-one function, and we're gonna discuss later what to do with that. Now, if you have a polynomial function that goes something like this, this would be a one-to-one function because the vertical line, it passes the vertical line test and it also passes the horizontal line test. So this function has an inverse. So back to our inverse function description. It says for any one-to-one function f of x equals y, so the input is x, the output is y, a function denoted with f with to the negative 1 there of x is an inverse function if the inverse function takes in y and it spits out x. Okay, so look how symmetric that this function f takes in x, spits out y, and the inverse takes in y, spits out x. It can also be written in as our function composition notation. So the inverse of f of x is x. And also, if we switch this around, f of the inverse of f of x equals x too. So when we run, in other words, when we run it through f and then through the inverse, we get x back. When we run x through the inverse and then f, we get x back in both cases. And when we are verifying if two functions are inverses, we don't have to do both. Like if one is true, the other one is going to be true as well. So you could choose one of these. Okay, also note that with the exponent negative 1 on x does not mean the reciprocal. And also, not all functions have inverses. So these are our facts about inverse functions. Let's take a look at some examples. So here's our example number 1. If a particular one-to-one function f of 2 equals 4 and f of 5 equals 12. What are the corresponding input and output values for the inverse function? So for f of x, we have the inputs and outputs as follow. The input is 2, the output is 4. And then when the input is 5, the output is 12. Now for the inverse, remember the inverse takes in the y and spits out the x. So it's gonna have 4 for the input and it's gonna give us 2 for the output. And also it's gonna take in 2 and spit out 5. So this is these are the inputs and outputs for the inverse. Okay, so we could also write that f with a -1 of 4 equals 2, and f to the -1 of 12 equals 5. So notice how the x and y switch places. That's going to be important. Now I want you to try this one. It says given that the inverse of h is with the input 6 is 2. What is the corresponding input and output values for the original function h? Okay, go ahead. Let me know if you have any problems with that. Okay, how to verify or to test the two functions f and g are inverses of each other. So basically, you have to take a composition of those functions. So f of g, if that gives you x in the end, then they're inverses. If it doesn't, then they're not inverses. You could also test g of f and see if it will give you x. So one or the other, again, you don't have to do both. So let's take a look. Example 2. We have f as 1 over x plus 2, and g is 1 over x minus 2. Is g an inverse of f? Let's see. So which one would be easier here? I think let's do g of f. G of f of x. So the g is 1 over something, and instead of that x, I'm going to put an f, 1 over x plus 2 minus 2. So also I'm going to apply my division by a fraction rule. To divide by a fraction means to multiply by its reciprocal. So I have 1 times x plus 2 over 1 minus 2. What is that equal to? So that's just x plus 2 minus 2. So I get x in the end. So, and that means that yes, g is a reciprocal of, inverse function of f. All right. Now you try it and check if f of x, which is x cubed minus 4, and g of x, which is the cube root of x plus 4, are inverses of each other. Let me know if you have any trouble doing that. And we're going to proceed to example 3. Which says determine inverse relationship for power function. So if f of x equals x cubed, the cube function, and g of x is 1/3 x, is g an inverse of f? Okay, let's see. So I think it's easier for me to actually put an f inside of g. So I'm gonna do g of f of x again. So g starts as 1/3 and then x. But instead of x, I'm gonna put in what I have for f, for function f, that's x cubed. So all I have is 1/3 times x cubed. So that's x cubed divided by 3, and that does not equal to x at all. So my conclusion is no, g is not an inverse of f. And I want you to try this problem by yourself. If f of x equals x minus 1 quantity cubed, and g of x is the cube root of x plus 1, are the inverses of each other. Again, try them and let me know if you have any problems.